So today we're going to be talking about how to solve for the height of a tree. So in this diagram you have a tree, the ground which is level and perpendicular to the tree, and a person who stands perpendicular to the tree. There are three ways that we're going to talk about to solve for the height of the tree. We're going to use similar triangles, trig functions, and the special relationships formed by right triangles. So the first method that we're going to use is similar triangles. As you can see in the diagram, H stands for the height of the tree, P stands for the height of the person, X stands for the length of the shadow, and D stands for the distance between the person and the tree. The proportion we are going to use is quite simple. It's H over P equals D plus X over X. The reason we have to use D plus X is because the height of the tree and the height of the person are proportional, which gives us our first ratio, and then the length of the long leg on the larger triangle is proportional to the length of the long leg on the smaller triangle, which, since they are nested, is X plus D. Once you simplify your proportion, you will come up with the equation Hx equals P times D plus X. Plugging in your variables and then solving it should be very simple from that point. The next method we have is using trig functions. There are three trig functions: tangent, cosine, and sine. We know in this instance that we need to use tangent because tangent is the opposite over the adjacent, in which case h minus p is the opposite of theta, which is our new variable. Theta represents the angle that is created by the hypotenuse of the triangle and D. So our equation is the tangent of theta equals h minus p divided by D, which is, once again, its tangent equals the opposite of theta over the adjacent of theta. So once you plug in your variables, you can easily solve this with a scientific calculator. The third method that we are going to be using to solve for the height of the tree is using the special relationships formed by right triangles. Now, because this is a 30, 60, 90 degree triangle, we know that D is 3 radical the short leg here, which is h minus p. We know that this is h minus p because h is the distance from the tree to the ground, and p is the distance to the bottom leg, D, here. So the equation we are going to use is D radical 3 plus p equals h. We need to add p in this instance because D radical 3 equals h minus p. So we have to add p to make it so that it just equals h. And then this will give you the height of, solving here will give you the height of the tree. So those are three easy ways to solve for the height of a tree using similar triangles, trig functions, and the special relationships formed by triangles. And the greatest part is all you need is the tree and another person.